Hi guys, in this video I'm going to show you how to draw graphs of functions with more than one domain. Before we get started, just want to make sure that we're totally happy with the words domain and range. Domain are the input values into the function, so effectively that is the x values, and the range are the output values. Essentially those are the y values. Your range is basically your smallest y value up to your largest y value, given by your function for those domains. So the first question that I have got is draw the graph of y equals f of x, where f of x equals 4 between these x values. So between -4 and -2, I need to draw the graph of y equals 4 because y equals f of x. So between -4 and -2, y equals 4. I then look at my next set of x values, which are between -2 and 2. And the function that I need to draw there is y equals x squared. So what I've got here, y equals 4, is going to be a horizontal line between -4 and -2. When I draw an x squared graph, that's going to be a curve or a U shape between these two values. And this part here, 8 minus 2x, so y equals 8 minus 2x, between 2 and 4 is going to be a linear graph with a negative gradient. And what will happen is these will all end up joining up because they are the end boundaries of the domain. So they will link up. So let's look at how we're going to do this. I've drawn myself a set of axes. So my first one was, let me just move that down for you. My first one was between -4 and -2. I need to draw the graph of y equals 4. So I just need to label on my y-axis. Should have done this before, sorry. And these got to -4. Okay, so I've got my axes all labelled. So between x equals -4 and x equals -2, I'm drawing the line y equals 4. Y equals 4 is going to be a horizontal line. I'll just plot the coordinates so it'll be easier for me to draw in. Here, here, here. I'm then going to look at the graph of y equals x squared. So I look at the graph of y equals x squared between all of the values between -2 and 2. So -2 squared is 4. That's good, that overlaps with that point there. -1, which would be the next one, -1 squared is 1, so that is going to be there. So when x is -1, the y value is 1, because when I substitute x equals -1, the output for that is 1. Then I need to go for the next one, which would be 0. 0 squared is 0, so I can put that on. Next one's 1 squared, 1 squared is 1, and then finally 2 squared. I know it says not equal to, but there will be overlap here, so I'm just going to do it anyway. So 2 squared is 4, 2 times 2 is 4, on there. I can now draw that nice quadratic shape that I was expecting there. Finally, I have got 8 minus 2x. Should have been organised with my pens here, sorry about this. Let's go with that one, purple. So here I've got 8 minus 2x. So my first x value, continuing on, is 2. So I'm going to substitute 2 into the x. So 8 take away 2 times 2, 8 take away 4 is 4. So when x is 2, the y value is 4. Then I'm going to do my x equals 3. So 8 take away 2 times 3. 2 times 3 is 6. So 8 take away 6 gets me 2. When x is 3, y is 2. And finally, when x is 4, 8 take away 2 times 4. 2 times 4 is 8. 8 take away 8 gets me 0. And there is my linear line with a negative gradient. So what you can see here is this is our graph y equals f of x. But between each of the separate domains, I should have done that in red to show that's between that domain. Put a little star there. Make it all clear and easy to follow. That one. So I've got 3 domains, 3 different functions for each of these parts that make up that one function as a whole. And that's all there is to that part. The other side of the question that you could potentially have, move that out of the way, is this question where you have got, here is the graph y equals f of x. Define f of x, stating clearly the domain for each part. So I've effectively got 3 different sections. I've got this linear section here. I have got this straight line part here. And that purple again. I have got that part there. So there are 3 separate parts to my graph of y equals f of x. So let's focus on the green bit first of all. So between x is 0 and x is 2, I have this function. So my domain is going to be between 0 and 2. I now need to work out the equation of this line. I know it goes through 0, 0. So the y-intercept is going to be 0. I need to work out the equation. I need to find the gradient, y equals mx plus c. So, change in y. So if I take 0, 0 and 1, 1, change in y is 1 over change in x, which is also 1. So the function for this, f of x, I should do this in black. F of x is equal to x for this domain here, because y equals x at this part of the graph here. Now my next part is between x is 2 and x is 4. So between 2 and 4, which is my next domain values. This is a horizontal line. This would be the graph of y equals 2. Therefore, for this part here, for this domain, it's going to be 2. Now this last part, finding the domain for you is going to be easy now because it's quite clear that it's between 4 and 8, so I can write that in. Remember, this is my last point, so I need to make sure that I have got the or equal to sign there. But to do this one's going to be slightly harder. I need to work out the full equation of this line. So what I'm going to do is I'm going to take 2 coordinates. I'm going to go 4, 2 as one of my coordinates. And I'm going to go 8, 0, just because it's one either end, nice values to work with. So I need to work out my gradient. So my gradient is going to be my change in y, so 0 take away 2, over my change in x, 8 take away 4. If you're not too sure of that, please make sure that you revise equations of straight line graphs. There's the gradient, so I get negative 2 over 4, which I'm just going to simplify to negative a half. So, going back to equations of straight line graphs, this is just my working down the right hand side here. I know I've got an equation y equals negative a half x plus c, where c is my y-intercept. Now it would be lovely if it was going through the origin, but it's not. It is going to go through a positive, sorry, let's put that back on there. It is going to go through the positive y-axis, and therefore I'm going to have to work this out. totally up to you which coordinate. You can use either coordinate. I'm going to go for 8, 0. So y in this case is 0. The x value is 8. So 0 equals negative a half times 8 plus c. 0 equals negative 4 plus c. Add 4 to both sides, you get 4 equals c. So the equation of this line here is y equals negative a half x plus 4. Now that I know that, I can put that in for the domain that I have identified for this part of the graph. Although it doesn't actually go through 4 on the diagram, that would be the equation of that line, and so we have to include the whole equation of the line, and therefore in here negative a half x plus 4. And that's it. That's all there is to drawing and sketching, identifying graphs of functions with more than one part to the domain. Part 2 of this question then says, state the range of f of x. So what I need to do is I need to look at this graph and I need to look my range and my y values. So my lowest y value is 0. It doesn't go below the x-axis. So my lowest y value is 0. If I label that I, and part 2 double I, the range is between 0. The range is greater than or equal to, because at this point here the coordinate is 0, so it can be equal to 0. The greatest y value that my function goes up to within this domain is 2. So I write in here f of x, because that's like my y, my function of x, all of it, the y. Here you could put y in here, I just put f of x, and we identified that the greatest possible value that it could be was 2, because that's the highest y value in that diagram. Hopefully that's given you a nice little snapshot of working with these types of questions, and you're feeling confident with this now.